In this presentation, simple presentation, we are going to learn the different jargons or terminologies used in data science. So we are learning about different terminologies of in data used in data science. So data science cannot exist without data. Data is the most important aspect of data science. That's why it's called data science. So now data uh, is basically, if you look at nowadays, the data is divided into two categories. One is structured data and another one is unstructured data. So structured data is always present in a tabular form, so we can use that. And unstructured data is basically available in a non-tabular form, such as text, images, audio, video, etc. But even then, to solve data science problem or build the models, we first convert the unstructured data into a structured data. That means in a tabular form. Now there is another term called sample. Now sample is nothing but a table containing values of independent and dependent variables. Now, so then comes sample size. Now sample size is basically the number of rows in a data table. And we use this sample to basically, whether it is structured data or unstructured data, we convert all the data into a table which has independent variables as well as dependent variable. But in certain cases there are no dependent variable, but so it will have multiple variables in the table, and that's how we convert the data into sample, which is in the form of a table, and then we start working on the project. As discussed, a table or sample has variables. It can contain, basically it contains two types of variables. One is response variable or dependent variable. Another one is predictor or explanatory or independent variable. So response variable is the basically is the variable that we are trying to predict using predictive model. So when we build a model in data science, this model predicts the value of dependent variable. It's also known as response variable. Now another variable or set of variables found in a sample is predictor. Basically it is explanatory or independent variable. That means the independent variables are not dependent on the response variable. So they're all each independent of each other. And when we build a model, basically it's a mathematical equation that we are solving through machine learning algorithm. So we insert those parameters and then use these independent variables in this mathematical equation to predict the response variable. In data science, we use machine learning basically to build the predictive models. And this predictive model is nothing but a mathematical equation solved by computer algorithms using historical data. So we use historical data and certain algorithms and we put them together to come up with a mathematical equation which is known as predictive model, which predicts the response variable. Now machine learning is nothing but a set of algorithms used by a computer to learn a model, predictive model. So it uses, this algorithm uses historical data as well as basically it uses historical data to build this model, which is nothing but a mathematical equation. Now machine learning has uh, two subsets. Basically there are different types of machine learning: supervised learning as well as unsupervised learning. But supervised learning has or must have response variable in the data set. But for unsupervised learning, there is no response variable. Unsupervised learning works on the data set which has only independent variables, while supervised learning works on a data set which has independent variables as well as dependent variables. That's why it's called supervised learning, because there is a response variable which is helping the machine learning to come up with a mathematical equation. While in unsupervised learning, there is no uh, dependent variable. So in supervised learning, what happens is we build models like linear regression, classification, while in unsupervised learning, due to the absence of dependent variable, it divides the data points into different clusters depending on how many clusters we want, or depending on the data itself. So it divides the data into different groups. In data science, to solve some of the complex problems, uh, we use neural networks, basically where simple machine learning algorithms may not perform so well, and there is a need for a complex algorithm which can solve a complex problem. So that's where neural network comes into picture. Now neural network, basically it consists of different layers, and each layer has multiple nodes. So it basically has input layer, then multiple or at least one hidden layer, and then output layer. Now, and each layer will have its own number of nodes. Now each hidden layer is connected to its previous and the next layers. It could be fully or partially connected. Fully connected means each layer, each node of a hidden layer is connected to each node of the next or the previous hidden layer. So now basically neural network is used for classification models, but it can also be used for estimation models, to build the estimation models. So and the difference comes at the end of the neural network, which is in the output layer. So output layer can be used for classification or estimation. Use deep learning to solve a complex problem, and basically we use deep learning for unstructured data such as text data or images or videos, audios. Those kind of unstructured data are used in deep learning to solve a complex problem. Now deep learning uses basically neural network to build a predictive model, but to build a deep learning, we need to have a very large number of hidden layers. So basically, it is not just one input layer and one or two hidden layer and one output layer. Of course, input layer is going to be single, output layer is going to be one. But in between, we have multiple hidden layers, and it's basically used for classification, but can also be used for estimation, or estimate the numerical value of the output. Now DL also, as it requires a large number of hidden layers, it also requires a very large data set. The sample size ranges anywhere between hundreds of thousands and millions for a higher accuracy. So if you want the highest level of accuracy, we need to have a very large number of data, a large sample size, as well as multiple hidden layers. And examples of deep learning is CNN, which is convolution neural network to solve computer vision problems. Then RNN, recurrent neural network. Basically, it is used for text related, model building. So predict the next word or predict the next. RNN can also be used for producing musical piece, or using historical data, of course, and also the different or even the music, as I said. Exploratory data analysis, also known as EDA, is a very important aspect of data science project. So it's basically it helps in understanding the behavior or the pattern in a data set. It also tells us the hidden story. So when we analyze the data, we explore the data, we start seeing the correlation between variables, different variables, and how each variable is able to tell us a story about that particular data set. So that's why EDA is an extremely important aspect of data science. That EDA uses like different graphical representations such as pie chart, histogram, bar chart, basically to see the pattern in the data. And also it makes use of tables and other numerical methods. So basically exploratory data analysis is a stage where a data scientist tries to see the pattern in the data, try to figure out what story this data is telling us, and how can we use this data to solve a much bigger problem.